Evening, guys. Today, the day 12 interdisciplinary area in robotics. This was the concept of today's, and when we go within the interdisciplinary areas in the robotics, we'll be getting that the robotics has been a multidisciplinary branch, and it has been conversion with the three branches like computer science, mechanical, and the electrical. And like that only here we can get it the what was the main concept over in the robotics and how we are going to use the particular concepts in particular making of a robot. Here we have that computer science, motion planning, artificial intelligence in electrical control schemes. And these were the topics which we are including at the robotics at nowadays to make the particular type of a robot in a most accurate process. In the computer science, it will be used for the uh, coding purpose in a like intelligent purpose or else for the particular command mode purpose to be giving the interaction between the person and the mission or robot something else. And the motion planning means that the point to point variances and the point of an areas which to be recognized in a particular area of dimensions and to be get the distance variable of in a distance variance, it will be calculated by the motion planning. In the artificial intelligence, it is mean that it like an intelligence robot which the human can think like that only the particular robot also can be think in the way of a human, and it can done the task by itself, and it can think by itself and make the particular task in a proper way. That is called as an artificial intelligence. And this artificial intelligence will be learning by the step by step processes in a particular way. And control schemes, in the control schemes we can get that what was the actuation systems will be worked to make proceeding of a robot from one point to the another point. And how was the control schemes mean that the control signals will be passed from one place to another place, how it is going to be executed in a particular way, and how it is going to be execution process will be done. Now we can see the clear view about this all the topics. Yeah, computer science. The computer science is the study of computers and computational systems. Unlike electrical and computer engineers, computer science deal mostly with the software and software systems. Yeah, you are right that people, which we have discussed at the earlier, the computer science will be the main role at the robotics. Why and how? This is our doubts. Now we can get within good answers. The computer science, it makes the main role in the robot to make the most accurate robot by the intelligent or else by the command mode probabilities. How it will be possible? The robot is in a mission, and the person is in a human that is going to be instruct the robot for the particular task. We are using the robot to do the particular task in a simple type of variances which the human can do, which the human cannot do. On that time we can use this we can use this robot for doing particular task. How the robot can understand our language? We are talking even at the Hindi, English, and multiple language we have, but the robot cannot understand that language. What was a language can understand by the robot? The mission level language. And 0 and 1, this is a binary level language. And how was the binary level language will be understandable by the robot, and how our language will be converted to the binary level language by using of the interfacing of a coding. The coding we call that was the interface between our humans and the robots. And whatever the instructions we are giving by the coding process, yeah, you move from here to there, and to be connecting with the interfacing and the particular area of working space with the particular area of dimensions. You have to work this particular task. We are instructing to the robot by our coding. Then the robot is going to be understand that particular coding. Why means that we are giving in the mission level language that we are giving by the coding process. That coding, how it is going to be transfer that data to the robot by any mission language like 0 and 1, 0 and 1. That coding, it is going to be decode that, or else encoding that particular data for a demodularization of the particular robotic memory allocations. In that memory allocation, the circuits will be passed, and that circuit makes that to be a robot in a most accurate process. Okay, the principles area of study within the computer science include artificial intelligence. Yeah, here we are going to be use, and what was the principles will be acted in the computer science we can learn here. The artificial intelligence, computer systems and networking security, and database systems, human computer integration. Yeah, one by one I'm going to explain the artificial intelligence, which I have said you are the previously, and next more topic also will be coming. And next we going for that computer systems, the computer systems that to be interacting with one to each other by the topologist systems. The topologist methodology, it will be to be interacting with one computer to the another computer, and hyperlinking. This also one type of interaction between one computer to the another computer interaction. This was the thing will be happen from to be intercoordinating between one computer to another computer. And then after networks, the networks is that to be it will be in the two type of categories, that is offline network and the online network. When we go within the online network, when our net connectivity has to be connect with the particular of two domains of a robot, and in that particular two domains of a robot has to be the internet connectivity. How was the interaction between two robots will be done? Either else by the Wi-Fi, either else by the Bluetooth, either else by the particular Wi-Fi modules, either else by the hotspot modules. Like that, it will be going to be interact. How it is going to be work means that yeah, in your home there is a one smart TV, and you have to going to be stream it your phone video at your TV. How it is possible? By it is going to be ask you to be on the Wi-Fi. Why means the Wi-Fi module is at the your TV. Then it is going to be release the particular signals. Then that particular signals, it is going to be catch by your mobile phone. Then the signal transmission will be done through the Wi-Fi module. Then whatever the streaming process you are going to do at your mobile phone, that streaming process is it is going to be a transfer for the particular TV. Like that only the network interaction will be over here. And when we come into the security, when we go within an online mode, there will be the IP protocols more at the IoT, Internet of Things. When we go within the Internet of Things, it is the deep most topic, that Internet of Things, the databases and the data manipulations. When we go with that, there has many IPs. IPs means intellectual property to be identifying for a particular IP address only, and particular the domain which we are giving the labeling for a particular task, that is called as an IP. And the particular IPs will be for different type of categories and different type of analytics. According to that categories, the IPs will be defined. That IPs will be categorized and to be executed in a particular process by using of a security. And when we go within a security, it needs a security. Why means when we are going to be interacting with the particular robot, it may be causes that any one person can hack that robot. Why means every electronic component can be hacked by any person. On that time, maybe it can be possible that any person can be hacked with that particular robot. On that time, we need the particular data transmission security. How it will be possible? There will be a two-layer security and three-layer security and single-layer security. According to the our particular task, we has to be use that particular security. There will be a firewalls that it is going to be resist that particular data. It need not to be go out from the particular area of a substance. Anyone can be attacked by the hacking also. It will won't be extract from that particular data modulation. In database systems, the database systems means it is nothing but that the memory allocations and the memory storaging. The database systems which will be storing the data particular which we are giving the feeding for that, or else be in interacting with the particular environment on that time. Like how our human brain will act like the abnormal memory and the normal memory, like that the data system will be in the robot also, like in a rom and the ram. The rom will be execute in the particular time which when the processing is going to be done, but the ram is going to be store the particular memory, particular data at that memory for the time period of long. And that is called as the database system. The data management, how some management will be done in that particular area, that is called as the data management database system. The human computer interaction, yeah, computer interaction means that whatever the gesture robot or else the interactive robot, like how we are talking with the particular robot. If we see the high for robot, the same replay will come for a high from that particular robot. How it is possible? Like the Alexa and the Hey Google, that will be works at particular area. That's why we are using the interactive processes, and it is going to be recognize our voice, and it is giving the interrelated answer for that. That is called as an artificial intelligence or an RPA development. The RPA development is called as this. The UI path RPA development is this, to be interacting with the two person, whatever the word we has given to that person a keyword for that, and it is going to give the exact answer interrelated max to max 98.6% interrelated to that answer. It is going to be give us vision and graphics. Yeah, vision and graphics means that with our naked eye we can see that when we go with another robots, we has to be the vision and the graphical representation of an area of allegation. Mean that the vision means there should be, we are going to include the cameras on that time. If we include the cameras, there will be an somewhat on the night time and the daytime, it has to be recognize the particular type of a task, and it need to be, the camera has a capability to be recognized in a particular daytime and the night time. Night vision has to be and the day vision has to be to detect the particular task and particular task variancy of a job condition. The graphical representation means the working space which we that is going to be work. It has to be calculated from the what was the distances, what was the wall variances will be, and what was the obstacles is there in this particular area. If the obstacles has came near to me, or else if the robot has went near to that obstacles, in the how many meter of a distance it has to be a stand, and how many distance it has to be maintained, that it will be done by this. And numerical analytics, the numerical analytics is nothing but the algorithms which we are giving the execution processes for the robot, and we are teaching the methodology that you have to learn this, you have to learn this, like how we are teaching the ABCDs and the particular things for another small child, like that the teaching methodology we are giving for the robot, that is called the numerical analytics. The programming languages that software engineers, bioinformatics, and data computing, the computer science of analytic algorithms to solve the problem and study the performance of a computer hardware and the software. Yeah, it in this particular computer science, not only in the software only, there will be a hardware circuit designings also. When we go with the electrical part, the PCBs will be, that PCBs is going to be execute particular task. The PCBs is going to be transmit the particular signal probabilities from one place to another place with the most accurate processor, that it is going to happen over here. That's why the signals are going to transmit from one place to the another place, and it is going to execute the particular task in the hardware process. In the software process, it is going to take the particular task from the gesture. Who is the gesture? Who is the person who is going to manage that particular robot? With the particular instructions of that person, the robot is going to work. This is all about the computer science, and now you can learn clear details about this computer science. Yeah, in the computer science, the main part is that coding and how it is will be executed. The functions will be executed. Here you can see that how was the instructions methodologies will be worked over here, and what was that instruction methodology. It is going to be executing particular task, and here you can see that example based the bits and hidden and dot bs dot select mean that the execution of a function, it is going to be execute in particular function on the particular variance of a time period. And what was the hiding mean that the particular task, it is going to be hidden on that time. We are going to be use this particular hidden, it is going to be execute in the BS state of a domaining, and the selection process like it is in a one line or second line or third line, like that the selection process will be done and functionation will be done like this. And the chips, when we go with another hardware technology, and here we can see that the hardware chips, how it is going to work. The hardware chips mean that, and how was in previously we have learned about the multiple chips like a 8 mega 382 and the 8058 microprocessor and the microcontroller, and MSP 430 processor, and each and everything we have learned. And like here we can see that how was the installation of a particular memory will be done, and the installation how it is going to be transmit the data from one place to another place in the mission level language in a particular time period. And this was this we call as the PCB board. In this PCB board, it has been interconnected with multiple oscillators and resistors, capacitors, and transmitters and the transformers and the relay conditions, and each and everything will be mentioned over in this particular PCB board. In this PCB board means that simply we can call like the motherboard at our system. Whatever the motherboard has to be consist, that all the things will be consist over here, and it is going to be executed. Now we can see here, and how was the chip types will be, and chip levels, how it is going to be execute in particular variance of the task, and the particular systems how it you can see that in our CPU, the central processing unit, there is a motherboard, and in the motherboard has in it the particular task of sockets like the CD drive will be, and the pen drive systems will be, and the VGA connections will be, and there will be the input and output of speaker connections. How it possible in the particular one board only? It will be possible by this PCB connectivity, and all the isolators has been connected for this, and multiple sockets has been connected. Mean that the motherboard is nothing but that the conversion of all the components, the combining of all the components in a particular place with the circuiting analyzing parts, that is called as the central processing unit. What was the central processing unit? It is a center, it is the main thing to be transmit the data from the input to output, or else output to input to transmit. This was the transmitting unit, which the transmitting the data from one form of the methodology to the another form of methodology. And here you can see that the intelligent robots and artificial intelligence based robots, which it will be worked within the particular task variances, and it makes the most accurate process, and it will be in the most how I can say the intelligent type of robots. It is going to work within a most intelligent purpose, and it is going to be a help for the human beings, and it is not for the helping nature only, that it is going to be think by itself, and it is going to give the solutions for the human beings at the some particular time. Yeah, why means the human being cannot recognize or remember everything our brain, but the mission can do it, that until and unless the memory has to be filled, the each and everything it can be stored, the machine can store, and it has a classification that to be yeah, the particular keyword it will be searching. Yeah, I am in the problem. Yeah, there is a problem that is in a keyword, or else I am in, that is a keyword. In these particular keywords, the robot is going to search that, yeah, any the previous topics is there from this keyword. Yeah, I am in the problem. Yeah, there is a particular topic, I am in the problem. For that solution which we are given for that solution, it is going to be repeated, or else according to our condition, according to our process, it is going to be we repeat the, but according to our condition, it is going to be give us the answer by converting or removing some particular topic from the previous one. That is called as an artificial intelligence based robot. In this, there will be the many type of algorithms will be executed. The algorithms is that to be think by itself to do the particular task in a mean variancy of a time. That is called as the artificial intelligence based robot. Now here you can see that the motion planning. The motion planning is a term used at the robots for the process of breaking down a desired movements task to desired motion that satisfy the movement constants and possibility operates some aspects of the movement. Yeah, as I said you at the previously at the start in beginning, this was the motion planning that to be executing a particular task in a safety momentum of in a manner to be optimize the aspect of movements of in a particular object or a particular working piece from different type of aspects and different type of optimization of particular object. It is called as the motion planning. Not only this, that the gunster navigating one or more unmanned aircrafts or drones in a cultured indoor or outdoor environment. Yeah, unmanned vehicle like a aircraft and the drones, we can use this motion planning. Why means it has to be land at the particular area, and it has to be when we use the particular drones for the delivery purpose, it has to go within the particular place. On that particular place, it need to get the landing space or in a landing area of a dimension. And how it can be calculated that it is a safe to landing or not, by using of this motion planning it will be executed that, yeah, this was a safe place, and this has the dimensions of this, and this was in a flattened surface. In the motion planning, what it is going to be done, the mapping, mapping process, it is going to be work over here the 3D space, that the motion planning strategies can still appeared in the 3D space in environmental disturbances such as wind and bad weather, in whatever the weather it be. But in the 3D motion planning, it is going to be a plan. The motion planning means nothing but that to be a plan that only, yeah, this only the particular area has to be launch, has to be drop my parcel, or else to do the particular task in this area only. But it is going to be manipulate, and it is going to be do the particular optimization according to environment also, like the either else at the and any wind or else any type of bad weather. Else it can be done at the flood type of conditions also, according to the condition, according to the particular navigation of a particular planning is motion planning. In this only has one type of planning. It is going to be a plan that yeah has to drop here or not. I has to do the particular task of this variance or not. It is going to be do the verification by before doing the particular task. After doing the verification by the motion planning, then after it is going to deliver the particular object in a particular area of time variance. And motion planning has several robots applications such as autonomy, automation, and robot design in a CAD software. Yeah, robot design can be done within a CAD software and the SolidWorks and Fusion 360. Robot design can done at the CAD modeling and the SolidWorks and the Fusion 360. And the when we go within a simulation process and we go within the interconnectivity process, we can go with a MATLAB also. If you know the real coding of a MATLAB, you can go through the MATLAB also. And mostly the designing process will be done through the CAD only. And as well as the application in other fields such as animation, digital characterize, video game, artificial intelligence, articulate design, robotic surgery, and the study of biological modulations of robot facility doing motion planning research include. Yeah, this was the thing which will be included in the different type of application processor also. The different type of applications that are in the video games and the digital characteristics, robotic service, and the architecture designing, artificial intelligence. In many ways, we can use this motion planning of a robot. The motion planning of a robot is a main concept to be included in a particular variance of a task in a particular way. This will be works for good amount to be plan the particular task in a mean of a time and to do the perfect task in that particular variance of time. It will be depending on the time and the planning. That is called as the motion planning. Mean that the momentum of a time can be executed in a particular surface of a planning. That is called as motion planning. And now we can go through another part.
So, our aim is to design and develop intelligent and autonomous robot. Now, we have seen how to collect the information of the environment with the help of sensors, with the help of cameras. Now, this particular camera could be either the onboard camera or the overhead camera. There could be multiple sensors. There could be a combination of sensors as well as camera, and we collect information of the environment. Once we have collected the information of the environment, now an intelligent robot should be able to take the decision as the situation demands. So, how to take the decision? How can a robot take decision? So, that I am going to discuss. So, we are going to start with a new topic that is called the topic 8, robot motion planning. So, in motion planning actually what we do is we try to plan the motion or try to find out the course of action while moving from an initial position to the final position. Now, let us concentrate. Let me consider that this is nothing but the tip of the manipulator. So, this is the initial position of the robot and the final position is here. So, starting from here, so it is going to reach this particular the final point through a number of intermediate points, and might be there could be a few obstacle sort of thing. So, it will have to avoid collision with the obstacle. So, how to determine the course of action or the path, that is the collision free path, that is the task of a robot. That means, to perform that particular task, the robot should have a proper motion planner, the path planner. Okay. Now, here I am just going to discuss like how to design and develop a suitable path planner or the motion planner for this particular the intelligent and autonomous robot. Now, if you see the robot motion planning, so this robot motion planning are broadly classified into two subgroups. So, these are broadly classified into two subgroups. So, these are broadly classified into two subgroups. Now, one is known as the gross motion planning or the free space motion planning, and another is your the fine motion planning or the compliant motion planning. Now, let me take one example. Let me take one example just to find out the difference between this gross motion planning or the free space motion planning and the fine motion planning. So, let us take one example. Supposing that say I have got one board something like this, and on this particular board say I will have to write say one word, say I am just going to write a word, say robot I am just going to write. Okay. Now, this is the blackboard on which I am just going to write with the help of a marker or a chalk. Now, if you just give the same task to a robot, to an intelligent robot, that intelligent robot will first try to find out the free space on this particular the board where it can write that particular the word. For example, say the board could be something like this. So, this is here, this is not the free zone. So, this is not the free zone. So, this is not the free zone. Okay. So, the board could be something like this. So, I am just going to show the free zone and your the dark zone sort of thing. So, this is actually the structure. So, something is written here and this part is not cleaned of this particular board. So, I cannot write anything on the this part where there something is written. So, how to write the word robot or the robotics. Now, if you give this particular task to the robot will first try to find out where is the free space where I can write down. So, this particular the word, that is the robotics. So, all such the letters I will have to write. Okay. So, first thing it will do is it will try to find out the free space. So, the first thing is it will try to find out the free space, and once it has got that particular free space, now it is going to write down the robotics. R will be written here. So, R O B O T I C S. So, the robot is going to write down robotics on the board. Okay. Now, let me repeat, the first thing you will have to find out the free space, and once you have got the free space, now you will have to write this particular the word, and these letters you will have to write down. And writing this particular letter on the board is not so easy, particularly for the robot, because whenever I am writing this particular the letter, so this particular marker is in touch with the board and there will be compliant motion, that is called the compliant motion. Okay. So, this particular the marker is in touch with your the compliant motion, marker is in touch with the board there, and I will have to put some force while writing, some amount of force is to be put, that is called the compliant motion. So, here there are two types of planning, one is called the free space planning, another is called the compliant motion planning. Now, compliant motion planning is if you want to write down, then how to put force, how to manipulate, and while writing. So, I am just gripping. So, that particular marker with the help of my finger, then I am doing some sort of manipulation. So, that I can write down R, O and all such things. Okay. So, I have got a planning To write R, I have got a planning. To write O, I have got another planning. To write A, I have got another planning, another sequence. Okay. And those things starting from our childhood, we run, we learn through a number of iteration, through a lot of practice. That is called the compliant motion planning. And free space motion planning, the purpose of free space motion planning is to find out the feasible and the infeasible zone. For example, say this is an infeasible zone, but this part is a feasible zone where I can write down one letter. Okay. So, the purpose of free space planning is to determine the feasible space and infeasible space, but the purpose of compliant motion planning is to write that particular the letter. So, this is actually your this is actually a bit difficult. So, this compliant motion planning or this particular fine motion planning is bit difficult. Okay. And this gross motion planning or the free space motion planning is easy, I should say. And here in this particular course, so I will be concentrating only on this particular the gross motion planning or the free space motion planning, but I will not be discussing the fine motion planning or the compliant motion planning, because this has been kept actually beyond the scope of this particular course. So, I will be concentrating on this particular the gross motion planning or the free space motion planning. Now, this gross motion planning or the free space motion planning can be once again subdivided into two parts. One is called the manipulation problem, another is called the navigation problem. The moment actually I am just going to take the help of one serial manipulator just to write something on the board, that is called the manipulation task, or the moment I am just writing something on this particular board. Okay. So, that is nothing but the manipulation task, and the moment that moving robot or the mobile robot is actually working, okay, that is nothing but is your the navigation task. In fact, we are planning to give some practical examples of this manipulation and navigation in this particular course, might be at the latter part. So, we are going to concentrate on this particular manipulation and navigation. That means, if I just want to put it in another way, that a serial manipulator or a parallel manipulator solves the manipulation problem. On the other hand, a mobile robot, it could be a wheeled robot or a multi-legged robot or a tracked vehicle, tackles the navigation problem. Okay. And let us see how to proceed further with different types of the motion. Now, this particular it shows, this sketch shows actually if this is the total time for planning. Now, the free space motion planning takes only a small part, small duration. On the other hand, the compliant motion planning takes the larger duration, and the total time is nothing but is your the total time for the motion planning or total task time. So, the total task time, if I divide, the free space motion time is much smaller compared to your the compliant motion time. But as I told, I am just going to concentrate in this course only on the free space motion planning. Now, this shows actually the sequence of robotic action, and you will see that all such things, all such modules I have already discussed. Okay. And now, I am discussing motion planning. So, if I complete this discussion on motion planning, you will see that all such modules of robotics have been touched. For example, say if I just want to solve one task with the help of a robot, the first thing is your the task identification. So, you will have to identify the task which is going to be tackled or solved with the help of a robot. Then we go for the motion planning, which I am discussing now. And once that particular the motion, the plan of action or the course of action has been planned, we go for the kinematic analysis that I have already done, already discussed. Then we go for the trajectory planning before the dynamics. So, dynamics also I have discussed. The control scheme also I have discussed, because you will have to realize that particular the torque with the help of a motor with a suitable controller. And once those things are ready, now we are in a position to generate that particular the motion. And this is actually in short the all the necessary modules of robotics. And as I told that in this course, I am just going to touch the fundamentals of all the modules. Okay. So, let us try to concentrate more on this particular the motion planning now. Now, if you see the environment could be either a structured environment, that is the known environment, or it could be unstructured. Now, if the complete information of the environment is known beforehand, that is called the structured environment. For example, say I am just going to solve a motion planning problem like this, where the environment is known. Let me take a very simple example. Supposing that say I have got say x and y in Cartesian coordinate system, and I have got a robot. So, the robot having say 2 degrees of freedom, very simple. So, this is L1, this is L2. Okay. So, this is the length of the first link, length of the second link, and this is the tip of the manipulator whose coordinate is x and y. Supposing that I am just going to give a task that you start from here, that is point S, and you reach the goal, that is point G. Okay. Now, the tip of the manipulator is going to start from here and it is going to reach the goal, and supposing that I am just going to put one condition or the constraint that the tip of the manipulator should not collide with any of the obstacle. Supposing that I have got one triangular obstacle, I have got one circular obstacle, I have got one line obstacle, and these are all 2D stationary or the fixed obstacle. Now, here the environment is known, this is a structured environment. Okay. So, we know this particular the static obstacles, we know their location, and I know my problem that the tip of the manipulator should start from here and it will reach this particular the goal. Okay. And this type of environment is known as the structured environment. Okay. Now, if I just modify a little bit, for example, say if I just consider that these obstacles are moving, for example, say this obstacle is moving in this particular direction with some speed. So, this is moving in this particular direction with some speed. So, this is moving in this particular direction or say this particular direction with some speed. Okay. Now, the problem becomes difficult, okay. And the position of the obstacles are going to vary with time, and that particular problem will become a problem of motion planning in the presence of moving obstacle. So, the path planning or the motion planning in the presence of the structured environment, that is called the find path problem, that is called the find path problem, and the motion planning in the presence of unstructured environment. So, this is known as your dynamic motion planning problem, dynamic motion planning problem, or the motion planning among dynamic obstacle or dynamic environment. Okay. So, I am just going to discuss like how to tackle the problem, that is your the find path problem and your this type of dynamic motion planning problem. And I am just going to discuss the working principle of a few tools, the tools for motion planning, and with the help of some example, I am just going to explain. Now, here the motion planning approaches, if you see, those are broadly classified into two subgroups. Now, one is called actually the global approach, or this is also known as act after thinking process, or this is known as the offline planning. Okay. And we have got another that is called the local approach, act while thinking process, or the online planning. Now, if the environment is known, if the structured environment we have, then we can go for some sort of global planning, global approach, or offline planning. Okay. But supposing that I have got some sort of the moving obstacles in the environment, the environment is dynamic. So, here, so this environment is your unstructured environment. So, you will have to go for the local approach or act while thinking process or online planning. Now, let us try to explain the principle of this particular both global approach and the local approach. Now, let us start with, so this particular the motion planning scheme. Now, if you see the motion planning schemes, those are broadly classified into two groups. One is called the traditional schemes or the algorithmic approaches, and we have got the non-traditional schemes using the principle of the soft computing. Now, here actually the traditional schemes are also known as algorithmic approaches. Those are once again classified into two subgroups. One is called the graph based techniques, and we have got the analytical approaches. Now, if you see, if you compare this graph based methods and the analytical approaches, the graph based method actually it was proposed first. For example, the visibility graph that was proposed first in the year 1969 by Nilsson. Okay. Then we have got the Voronoi diagram, cell decomposition, tangent graph, accessibility graph. So, these are all graph based methods. On the other hand, actually we have got some analytical approaches. For example, say we have got the potential field method, we have got the path velocity decomposition, then we have got the incremental planning, probabilistic approach, then comes relative velocity approach, then reactive control scheme or behavior based robotics, etc. Okay. So, we have got a large number of approaches, large number of methods to solve this particular the motion planning problem. Now, on the non-traditional side, in fact, we have got a few approaches like the motion planning approaches using the principle of fuzzy reasoning tool, using the principle of the neural networks, using the principle of the combined neurofuzzy system, and so on. Now, those things actually is beyond the scope of this particular course. So, this will not be taught in this particular course. So, here actually I am just going to concentrate only on the traditional schemes or the algorithmic approaches, and both the graph based techniques as well as the analytical approaches we are going to discuss, and we will see that how to solve that particular the find path problem and dynamic motion planning problem. Now, here, so we are going to start with say the graph based technique which is known as the visibility graph, and this particular visibility graph as I told. So, this is the first approach which was proposed in the year 1969 by Nilsson. Okay. And here the principle is very simple. Now, for simplicity we are considering that the robots are point robot. So, we are just going to consider the point robots, okay. And we are going to consider that the obstacles are stationary, that is the fixed obstacle. Okay. Now, the problem scenario is very simple, and this type of problem is known as the find path problem. So, this is known as the find path problem. That means, starting from an initial position, so it will have to reach the goal by avoiding collision with this particular the static obstacle. Now, let us try to see. So, this is the starting point for this particular point robot, and for simplicity we are going to consider the point robot, and this is the goal. And here we have got some obstacles like we have got the obstacle like. So, this is obstacle 1, okay. Here we have got say obstacle 2, and these are all 2D obstacle, stationary obstacle. Okay. So, this is your another obstacle. Now, according to this particular method, so we will start from here. Now, if there is no such obstacle, so very easily you can connect this S and G by a straight line, and that will be the best path or the optimal path. That will be the collision free and time optimal path could be, but because there is no such obstacle. But due to the presence of this particular obstacle, so the robot will have to find out a feasible path, so that it is not going to collide with this particular the obstacle. The rule is very simple. The rule is as follows: it connects those vertices of obstacle which are visible from one another. Now, let me start from here and let me try to look towards the goal. So, starting from here, if I look towards goal, so this particular vertex is visible, this is also visible, this is also visible. So, you draw one line here, you draw another line here, you draw another line here. Now, you come back here. Now, from here you look into this. So, this particular vertex is visible, this vertex is visible, this is also visible. So, the visible vertex you connect by the straight line, visible vertex you connect by the straight line, and similarly from here. So, this particular vertex is also visible, but this is not visible, this may not be visible, this is also not visible. Now, from here, so this particular vertex is visible, so this vertex is also visible. Similarly, from here, so this is also visible, this is also visible, but this is not visible, this is also not visible, this is also not visible. Now, from here, so the goal is visible, then from here, so this is visible. So, from here, so this is visible, from here this is visible. Okay. Now, so another thing is from here, so this is also visible, okay, and this is also visible. Now, if I just do the numbering, say it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and this is G. Okay. So, I can write down the different feasible paths. For example, one path could be starting from S, you go to 2, then 2 to 8, 2 to 8, then 8 to G, 8 to G. Another path could be that you start from S, then you go to 3. So, you come here, then you go to 6, and then you go to G. Similarly, there could be many other possible combination, possible sequence. Okay. Now, out of all the possible sequences, you can find out the time optimal path, the time of these are all collision free path, and if you want to find out collision free at the same time optimal path, we will have to take the help of some optimization tool. But Nilsson did not use any such optimization tool. He could give all such feasible paths, and then he concluded that starting from S to reach this particular goal, there are many such feasible collision free paths, and out of all the feasible paths, the robot will have to choose one. This is actually the principle of the visibility graph.
Artificial intelligence electrical. Artificial intelligence describes a wide variety of systems built to intimate how a human mind makes discipline designs and solving problems for desired. Yeah, here you can see that the artificial intelligence are the electrical. And how is the artificial intelligence? Yeah, we have learned that the artificial intelligence is in the subdomain of computer science. It is called like the specialization. And if we are the artificial intelligence is mainly work in the subdomain like that, the algorithms like the NumPy, pandas, and the keras and NimPlotP, the libraries will be executed in the artificial intelligence. But here we can see that in the electrical also can be used by the artificial intelligence. The artificial intelligence describes a wide variety of systems built in the implementing how a human mind makes decision and solving problem for desired. Researchers and engineers have explored how different types of AI can be applied to electrical and computer system. These are some of the forms of AI that are most commonly incorporated into the electrical and the computer engineering. Yeah, here you have seen that the electrical and the computer engineering of a computer systems, it is going to be work with the artificial intelligence. The artificial intelligence, it is going to be help them to be do the circuiting analyzing and the circuiting designing. And when we go within the computer science, the coding part will be mainly executed by the libraries. On that time, the artificial intelligence is going to be used for the computer science part. And it is going to give the particular type of intervariancy of time variables. Uh, Export systems solving problems with an interfacing engine that draws from a acknowledged basic achievements with the information about a specialized domain, and mainly in the form of in than rules in use since the 1970s. These systems are less virtualized than a number of forms of AI, but generally easier to program and maintain. The expert system that to be mean the solve to the expert system. When we go within the artificial intelligence, and we'll be getting the expert system and the physiologic control system. In the physiologic control system and the expert system, when we go with the expert system, the solving of a problem, it will be done. Solving of a problem, it will be done by this particular algorithm, and it is going to be an interface engine that draws from a acknowledging of a cubed with the information but the specialized domain. Mean that the specialized domain mean the particular task, I mean that the particular job condition which we are doing, on that particular job only it is going to be execute, not it is going to be deviate into the another task. In that particular task, in that particular working process, it is going to be execute. That is called the extract systems, and mainly in the form in the rules. And it has the particular rules to do this particular task in this type of variance and this type of rule, not in the another particular rule. This will be executed over here in use since the 1970s. These systems are less virtualized than newer forms of AI, but generally easier to program and maintain. Yeah, for the AI, it is generally easier to program. How we are going to use the coding at the C and the C++, Python, like that only the coding will be, but somewhat small implementation will be done. The implementation will be done by using of algorithms or using by the libraries, and that we has to know that where we has to use a particular library and what was the particular algorithms which we has to use for particular type of a task. If you know that particular thing where we has to insert and where we has to get the particular task, then you're the person can get the everything by the artificial intelligence based systems. You can do it by yourself. That you has to know. And physiologic control system, when we go within the physiologic control system, make it possible to circuit rules for how machines respond in input that account. In the fuzzy logic control system mean that it makes the possible creative rules. Mean in the above export system there has been the particular rules you has to be followed, but here in the fuzzy logic control system you can create by yourself that rules for the mission responsibility. Mean that according to the working task, according to the working job condition, you can make the rules by yourself to inputs that account for the continuum of possible conditions. Continuing often the possible condition, it will be executed rather than the strategical forward of a binary. The binary numbers, how it is going to execute the particular rules that you are going to instruct that you has to go there and do the particular task. You have given the instruction, and then that data has to be convert to the mission. How it is going to be convert? It is going to be convert in the binary format. You're giving in the digital format, it is going to be convert into the binary format. That binary format it is going to be delivered for that particular robot. The particular robot it is going to be understand that yes, this was my task, I have to complete this task in this type of mean vacancy of time. And here you can see that the mission learning. Mission learning is nothing but that includes a broad range of algorithms and statistical models that make it possible for system to find patterns. Yeah, here you can see that the mission learning mean the mission it is going to be learn from the particular person. How it is going to be possible? By using of algorithms and statistical models. Statistical models means that the classifications which we are going to be trying for the machine learning. In the machine learning, there is going to be the training and the testing process when we do the coding. And after doing of coding, while we are going to be execute, there will be the training and the testing process. In that training and the testing process, it is going to be do that. Yeah, this is in a training, the 10,000 times training and the 30,000 times testing. After doing of the training and the testing, then after the output will be coming out, and system and find patterns, draw inter- interferences and learn to be perform the task with specific instructions, and how the particular task will be drawn and the particular pattern. And the particular pattern means that in the format which we need it, in a which format, either else the css format or xlmi format, or else in the yeah, xlmi file and the css file. There will be an api keys and the um, yeah, api, css and the xml formats. What was the this particular formats it will be, and this particular format how it is going to be giving a particular pattern of the particular data. It is going to be manipulated and going to be executing with the particular algorithms, and it giving the output by the instruction set. Okay, then when we go within the artificial neural network, are specified types of machine learning system that consist of artificial signal process designed to impact the structures, and function of binary. Yeah. Here you can see that artificial neural network. Neural network means the data has to be transmitted. The data has to be interconnected between one device to another device. The A device to B device, what was the interconnection between that, and the input and the output, the signal transmission, it all comes under the neural network. Neural network means in the fraction of a second, the data has to be transmitted from one type of an object to another type of an object. That is called as the neural network. The network, it is going to be a connector within a two particular task. That is called a neural network. The neural network, the network observes and learns, and the synthesizes and transmits the data to and process information as it passes through multiple layers. Yeah, it is going to be transmit in the multiple layer. How in the neural network it is going to be formed is that if you touch a particular object, in that particular object, it is going to be give the sense for the sensitivity of grippers, sensible grippers for robot, and it is going to be transmit the data from here to the brain. Brain means we have a brain, but the robot has the microcontroller or else a microprocessor. The microprocessor, if we think that the data, it is going to be processed in the microprocessor, and it is going to be to the processing system, and it is to ensure that you have to pick that right thing. Yeah, it is right, you have to pick that the whatever the memory is, that it is going to be give the instruction for this and re-instruction to picking that. How it is possible that why means while we are doing the coding, the particular classification, it is going to be classify that particular object. Yeah, it is in the particular object, it is in the cylindrical object, it has to be catch it, or else it is in the particular color, and it is in the particular shape. That the classification which we are predefined for the data set, according to that data set, it is going to pick up that particular object, and it is giving the output. In the deep learning, is a form of machine learning based on artificial neural networks. Yeah, here there will be the neural networks, and in the deep learning, interconversion of a machine learning and the artificial neural network. What we think that in the machine learning there is what that the algorithms. When we go with an artificial neural network, the data transmission, the neural data transmission which we are doing, and that is called as a deep learning. The deep learning architectures are able to process hesitate of an increase and abstract features, making it especially useful for purpose like speech and image recognition and neural language processing. In the neural language processing means NLP and neural language processing, the speech and image recognition. When we go with the deep learning, firstly we need to go with the classification of data sets. That in the data set, in the deep learning, there will be one data set. The data set, it is going to be extract the data from particular area by using of coding by the different type of classification. We can use the classification from the net, like the kaggle.com, or else from the Google Lens. We can use the multiple classification. Why means if we use the Kaggle, it is the best. Why means there has the multiple data sets that if you take the one particular object, there is one cat, the classification will be size, shape, and color, and what was the condition, like a facial expression, each and everything in the multiple times. If you take the one particular object like cat, in the thousands of images, thousands of particular differences will be in the Kaggle. On that time, if we integrate it with the Kaggle, then we can get the exact output that in the real world, if there is any type of cat and the dog, it can easily classify that, yeah, this is in a cat and this is the dog. Why means the dog has the ears into the up and it has a tail at the somewhat long, and this was the classification. The dog will be sit like this and the tongue will be like this. But in the cat, the tongue will be in a small, and the classification, the blue color eyes will be, and the shorter often a tail, like that. The classification will be done at the deep learning image processing. Sorry, image recognition. Image processing is another thing. Image recognition is another thing. And likely the speech recognition means the NLP, the natural language processing. The natural language processing means in our wavelength of speaking. While I am speaking, there every voice having the frequency, one frequency. That frequency it is going to be a cast. That the natural language processing means that the NLP is nothing but that it is going to be a pick the variancy of that graphical representation. It is going to be do by itself that the graphical representation, how much the pitch it is coming of in a voice and how much low pitch it is coming, and what was the exact voice that I'm giving. And if we talk at the normally, it will be another voice, and if we go within the particular the phone call, it will be in a somewhat another voice. Why means the data set which we are receiving, that particular data, it will be received by like that. The natural language processing means the exact data it is giving to the output. The wavelengths it is going to be calculated in according to that wavelengths, it is going to manage in a particular way. Yeah, if the base has to be in the two condition only, it will be maintained in that particular condition of two only, that base. How if you do the larger and the smaller also, the pitch level it is going to be maintained in that level only. That is the natural language processing. It will be works in the deep learning. And control schemes, when we go within the control scheme, the control scheme is nothing but that an adaptive control scheme is developed for the robot manipulator to track and distract a trajectory as closely as possible in speed of wide ranges of. In the manipulator, there has been a different type of the rotations and the coordinate systems will be acted. On that rotations and the coordinate system will be acted, the control schemes. The control schemes is nothing but that it is going to be give the trajectory planning for that mapping. Whatever the mapping which we are giving in that 3D dimension, the X, Y, Z, in the 3D dimension, that mapping it is going to use within the trajectory. The trajectory is nothing but the control schemes. Mean that it is going to be control that particular device in a particular area of an angle. That's why the trajectory will be acting, okay, as closely as possible in inspect of a wide range of manipulator motions and a parameter and Fourier criteria of likes and payloads. The presented control schemes has two components, like a normal control and the variational control. Mean that in the previous lectures we have discussed about the control system, what was the control systems will be and how it is going to be executed. Like that only here we have in it the different type of trajectory plannings in the control systems. According to that two, I mean that the schemes has two components. The two components means that the links and the joints will be executed in the particular variance of time. That is one type of coordinate. That coordinate it is called as the planning of a trajectory in the 3D motion planning. That is virtual control. The normal control and the generated form of directory calculation of a manipulator dynamics along a desired trajectory drives the manipulator to neighborhood of the trajectory. Yeah, trajectory planning is how I can need to say you miss. Yeah, there is an in the mathematics you learn that about a parabola and the trajectory and horizontal, that problems. On that time, how was the parabola it is going to work, and how was a motion planning it is motion it is going to work, and the diameter and the distance of that particular area variances, that is called as the, like that it is called as the trajectory. The trajectory we are going to plan from the working piece to the particular the robot, where the robot will be and the way the working piece will be interaction between these two, that is called the trajectory planning. Then a new adaptive regulation schemes, the adaptive based on the Le Pneu direct method, which generates the what vertical control that regulates the perfusion in the velocity and describe the trajectory. Yeah, the variational control systems which will be executed in a particular task in a mean variance of time, and how the trajectory will be work if there is any one object. The we has to calculate that particular object and the robot distance, what was the working space and what was the object place, and the calculation in the 3D dimensional way, and how was the working space will be if the robot will be have any disturbance or else has to be collide with any particular object or not, and how was the parabolic actions will be when it is going to be lift at the upside and it is going from the left and right side. How the trajectory planning mean that how long it can go, and how what can be it it can be directions of that particular robot. The robot has to be move in a freer way and normal way, that is called as the trajectory planning, it which will be used at the control schemes. This is all about today. Thank you so much.